Welcome to the Construction Electrician Red Seal exam practice. This video contains 100 practice questions to help you prepare for your certification exam. Let's begin. This exam covers the following major work activities: common occupational skills, generating and distribution systems, wiring systems, motors and control systems, signaling and communication systems. Question 1. When performing a lockout/tagout procedure on a 600 volts motor starter, what must an electrician verify after applying the lock? A. The motor can still operate in emergency mode. B. All downstream loads are still receiving power. C. The control transformer secondary voltage remains active. D. Zero energy state by attempting to start the equipment. The correct answer is D. Zero energy state by attempting to start the equipment. After applying a lockout device, the electrician must verify zero energy state by attempting to start the equipment. This confirms the energy isolation is effective and the equipment cannot be accidentally energized. Simply applying the lock is insufficient. Verification through attempted operation is a critical safety step. Question 2. An electrician discovers that another worker has placed a lock on a disconnect switch needed for the current job. What is the correct action? A. Remove the lock since the other worker is not present. B. Contact the lock owner and wait for their authorization. C. Cut the lock and replace it with your own lock. D. Proceed with the work using insulated gloves for protection. The correct answer is B. Contact the lock owner and wait for their authorization. An electrician must never remove another worker's lockout device. The correct procedure is to contact the lock owner directly and wait for proper authorization or their return. Each lock represents a worker's life. Removing it without authorization could result in serious injury or death to the lock owner. Question 3. What is the primary purpose of a megometer when testing electrical installations? A. To measure circuit current draw under load conditions. B. To measure insulation resistance between conductors and ground. C. To detect voltage presence in energized conductors. D. To measure conductor temperature during operation. The correct answer is B. To measure insulation resistance between conductors and ground. A megometer, also called a megger, is specifically designed to measure insulation resistance between conductors and ground or between conductors. It applies a high DC voltage and measures the resulting leakage current to determine insulation quality in megohms. Question 4. When rigging a heavy transformer for overhead lifting, what must be verified before the lift begins? A. The transformer nameplate matches the purchase order. B. The lifting points, sling angles, and load capacity are adequate. C. The installation location is ready for final connection. D. The oil level is sufficient for immediate energization. The correct answer is B. The lifting points, sling angles, and load capacity are adequate. Before any heavy lift, the electrician must verify that all lifting points are rated for the load, sling angles are within safe limits, typically 60 degrees or less from horizontal, and the equipment's rated capacity exceeds the actual load. Improper rigging is a leading cause of workplace injuries. Question 5. When interpreting a one-line diagram, how is a normally closed disconnect switch typically represented? A. Two parallel lines with a diagonal slash through them. B. A circle with an X inside and a filled contact point. C. Two angled lines meeting at a pivot with a solid connection. D. A rectangle with internal zigzag lines representing resistance. The correct answer is C. Two angled lines meeting at a pivot with a solid connection. A normally closed disconnect switch is shown on one-line diagrams as two angled lines meeting at a pivot point with a solid or filled connection dot, indicating the contacts are closed in the normal state. This differs from normally open contacts which show a gap at the connection point. Question 6. A project requires installing 500 meters of conduit before the concrete pour scheduled for tomorrow. Only 300 meters of conduit are available. What is the best course of action? A. Complete the available section and delay the concrete pour. B. Substitute a different conduit type that is readily available. C. Notify the supervisor immediately to explore supply options. D. Begin installing the available material without informing anyone. The correct answer is C. Notify the supervisor immediately to explore supply options. Material shortages require immediate communication with the supervisor. They can explore expedited delivery, coordinate with other trades to adjust the schedule, or authorize approved substitutions. Working silently or making unauthorized changes can create costly rework and project delays. Question 7. When installing threaded rod supports for a cable tray, what determines the maximum spacing between hangers? A. The visual preference of the building owner or architect. B. The ceiling height above the finished floor level. C. The conduit size running parallel to the cable tray. D. The cable tray width, fill weight, and span rating chart. The correct answer is D. The cable tray width, fill weight, and span rating chart. Cable tray hanger spacing is determined by the manufacturer's span rating chart, which accounts for tray width, anticipated cable fill weight, and structural loading. Exceeding the rated span can cause tray deflection, cable damage, and potential system failure. Question 8. When installing seismic bracing for electrical equipment, what angle provides optimal lateral restraint? A. Bracing at any angle is acceptable if properly anchored. B. Horizontal bracing parallel to the equipment face only. C. Bracing at 45 degrees from the vertical support member. D. Vertical bracing with connections at top and bottom. The correct answer is C. Bracing at 45 degrees from the vertical support member. Seismic bracing at 45 degrees from vertical provides optimal lateral restraint by effectively transferring horizontal seismic forces to the building structure. This angle balances tension and compression loads in the brace members during seismic events. Question 9. During commissioning, a motor runs in the wrong direction after initial energization. What should be done before reversing two-phase conductors? A. Check the motor nameplate for correct voltage rating. B. Verify the driven equipment allows reverse rotation safely. C. Measure the current draw on all three phases. D. Replace the motor starter with a reversing contactor. The correct answer is B. Verify the driven equipment allows reverse rotation safely. Before reversing motor rotation, the electrician must verify that the driven equipment can safely tolerate reverse rotation. Some pumps, fans, and machinery can be damaged or cause injury if run backwards. The equipment manufacturer's documentation should confirm rotation direction requirements. Question 10. What documentation must be completed as part of the system startup procedure for a new electrical distribution system? A. As-built drawings showing only conduit routing changes. B. Test results, equipment settings, and operational verification records. C. Supplier invoices and warranty registration forms only. D. Building permit application with estimated completion date. The correct answer is B. Test results, equipment settings, and operational verification records. System startup documentation must include all test results, protective device settings, operational verification records, and any deviations from design specifications. This documentation becomes part of the permanent building record and is essential for future maintenance and troubleshooting. Question 11. When mentoring an apprentice on conduit bending, what teaching approach is most effective? A. Demonstrate the technique, then observe their attempts with feedback. B. Provide written instructions and leave them to practice alone. C. Assign the task and check only the finished result. D. Describe the theory without any hands-on demonstration. The correct answer is A. Demonstrate the technique, then observe their attempts with feedback. Effective mentoring combines demonstration with supervised practice and constructive feedback. This approach allows the apprentice to see correct technique, attempt it under observation, and receive immediate correction. This builds both skill and confidence more effectively than passive learning methods. Question 12. When installing a 200 amps residential service entrance, what is the minimum size copper conductor required for the ungrounded service entrance conductors? A. 3/0 AWG copper with 75°C insulation rating. B. 2/0 AWG copper with 90°C insulation rating. C. 4/0 AWG copper with 60°C insulation rating. D. 1/0 AWG copper with 90°C insulation rating. The correct answer is A. 3/0 AWG copper with 75°C insulation rating. For a 200 amps residential service, applicable ampacity tables specify 3/0 AWG copper conductors when using 75°C rated insulation. The conductor sizing must match both the ampacity requirements and the terminal temperature ratings of the connected equipment. Question 13. A three-phase 600 amp service shows unbalanced currents of 580 amps, 590 amps, and 420 amps on phases A, B, and C respectively. What is the most likely cause? A. Improper load distribution with excessive single-phase loads on phase C. B. Defective current transformer on the phase C metering circuit. C. Incorrect conductor sizing on the phase C service entrance cable. D. Utility supply voltage imbalance affecting phase C current flow. The correct answer is A. Improper load distribution with excessive single-phase loads on phase C. Unbalanced currents with one phase significantly lower typically indicate improper load distribution, with too many single-phase loads connected between the other two phases and neutral. This creates higher currents on phases A and B while phase C carries less load. Question 14. What is the maximum standard rating for a single-pole circuit breaker protecting a 14 AWG copper branch circuit? A. 20 amperes maximum for any residential application. B. 15 amperes maximum for standard branch circuits. C. 25 amperes maximum when protecting motor loads. D. 30 amperes maximum for continuous duty circuits. The correct answer is B. 15 amperes maximum for standard branch circuits. A 14 AWG copper conductor has an ampacity that limits overcurrent protection to a maximum of 15 amperes. This is a fundamental sizing requirement that protects the conductor from overheating under fault or overload conditions. Question 15. When installing an AFCI breaker, what wiring configuration must be followed for proper operation? A. Load neutral connects only to the AFCI breaker neutral terminal. B. Load neutral connects to breaker neutral terminal and panel neutral bar. C. Load neutral bypasses the breaker and connects directly to neutral bar. D. Load neutral and ground share a common connection at the breaker. The correct answer is A. Load neutral connects only to the AFCI breaker neutral terminal. AFCI breakers monitor both hot and neutral conductors for arc signatures. The load neutral must connect only to the breaker's neutral terminal, not to the panel neutral bar. Connecting to both locations creates a parallel path that prevents proper arc detection. Question 16. A GFCI receptacle trips immediately when the test button is pressed but will not reset. What is the most probable cause? A. The line and load terminals have been connected in reverse. B. The receptacle is defective and requires replacement. C. Downstream wiring has a ground fault that prevents reset. D. The circuit breaker supplying the receptacle has tripped. The correct answer is A. The line and load terminals have been connected in reverse. When line and load terminals are reversed, the GFCI test function works, trips the device, but the reset mechanism cannot function because power enters through the load side. Correcting the terminal connections resolves this issue. Question 17. When installing a panel board in a damp location, what installation requirement applies? A. The enclosure must be mounted flush with the finished wall surface. B. A weatherproof cover must be installed over the panel door. C. The enclosure must be NEMA 3R rated or equivalent for wet locations. D. Standard indoor panels are acceptable with silicone sealant around edges. The correct answer is C. The enclosure must be NEMA 3R rated or equivalent for wet locations. Panel boards in damp or wet locations require enclosures rated for the environment, such as NEMA 3R or higher. These enclosures prevent moisture intrusion that could cause corrosion, insulation breakdown, or electrical faults. Question 18. During maintenance on a 600 volts distribution panel, what must be verified before removing a bucket-style circuit breaker? A. The main breaker is in the closed position for safe removal. B. The breaker trip setting matches the original installation specifications. C. The downstream loads are operating normally before interruption. D. The bucket is racked out and the contacts are visually confirmed open. The correct answer is D. The bucket is racked out and the contacts are visually confirmed open. Before removing a bucket-style, draw-out, breaker, it must be racked to the disconnected position with visual confirmation that the primary contacts are fully separated. This isolation prevents accidental contact with energized bus bars during removal. Question 19. When installing a three-phase online UPS system, what grounding consideration is critical? A. Only the battery cabinet requires a dedicated ground connection. B. The input and output neutrals must be bonded at the UPS only. C. Separate grounding electrodes for input and output are required. D. The UPS chassis ground must bond to the building ground system. The correct answer is D. The UPS chassis ground must bond to the building ground system. The UPS chassis must be properly bonded to the building grounding system to provide a low-impedance fault current path and maintain equipment safety. This connection is critical for both personnel protection and proper operation of overcurrent protective devices. Question 20. A surge protective device indicator shows the unit has failed. What should be checked before replacing it? A. Whether the connected loads experienced any damage from surges. B. The building lightning protection system grounding resistance. C. If the UPS battery backup runtime is still adequate. D. The neutral to ground voltage to identify potential wiring faults. The correct answer is D. The neutral to ground voltage to identify potential wiring faults. Before replacing a failed SPD, checking neutral to ground voltage can reveal wiring problems that caused premature failure. Elevated NG voltage from a loose neutral, shared neutrals, or improper bonding can stress SPD components and cause repeated failures. Question 21. What is the primary purpose of the grounding electrode conductor in an electrical system? A. To carry fault current back to the transformer for breaker operation. B. To provide a reference to earth potential and dissipate static charges. C. To serve as a return path for normal operating current. D. To protect conductors from physical damage in exposed locations. The correct answer is B. To provide a reference to earth potential and dissipate static charges. The grounding electrode conductor connects the electrical system to earth, establishing a reference to earth potential and providing a path to dissipate static electricity and lightning-induced surges. It does not carry fault current during normal overcurrent device operation. Question 22. When installing a ground fault protection system on a 2000 amp service, where should the ground fault sensor be located? A. On any single-phase conductor downstream of the main breaker. B. Encircling all phase conductors and the neutral at the service entrance. C. On the grounding electrode conductor near the main bonding jumper. D. Around the equipment grounding conductor only at the first panel. The correct answer is B. Encircling all phase conductors and the neutral at the service entrance. Ground fault sensors for service entrance equipment must encircle all phase conductors and the neutral together. This configuration detects the imbalance created when fault current returns via the grounding system instead of the neutral. Question 23. When installing a lightning protection down conductor, what routing principle must be followed? A. The conductor should follow the shortest path with minimal bends. B. Horizontal runs are preferred over vertical runs for safety. C. Sharp bends are acceptable if the conductor is properly supported. D. Routing through metallic conduit provides additional protection. The correct answer is A. The conductor should follow the shortest path with minimal bends. Lightning down conductors must follow the shortest, most direct path to ground with minimal bends. Lightning current follows the path of least inductance, and bends increase inductance, potentially causing side flash to nearby objects. Question 24. Ground resistance testing shows 35 ohms for a grounding electrode system that previously tested at 5 ohms. What is the most likely cause? A. The testing equipment requires recalibration before use. B. Soil moisture conditions have changed significantly since installation. C. A broken or corroded connection in the grounding electrode system. D. Increased electrical loads have raised the ground resistance value. The correct answer is C. A broken or corroded connection in the grounding electrode system. A significant increase in ground resistance typically indicates a broken or corroded connection in the grounding electrode system. While soil conditions affect readings, a 7-fold increase strongly suggests a physical discontinuity rather than environmental changes. Question 25. When connecting an emergency generator to a building electrical system, what prevents backfeed to the utility? A. A fuse disconnect switch rated for the generator output. B. A transfer switch that mechanically interlocks normal and emergency sources. C. An overcurrent protective device sized for generator short circuit current. D. A time delay relay that sequences the generator connection. The correct answer is B. A transfer switch that mechanically interlocks normal and emergency sources. A transfer switch with mechanical interlocks physically prevents simultaneous connection of the generator and utility. This mechanical interlock ensures that only one source can be connected at any time, preventing dangerous backfeed to utility lines. Question 26. When installing a battery bank for a DC backup system, how should the batteries be connected for 48 volts output using 12 volts batteries? A. Connect 4 12 volts batteries in parallel for increased capacity. B. Connect 4 12 volts batteries in series for the required voltage. C. Connect 2 12 volts batteries in series parallel configuration. D. Connect 8 12 volts batteries alternating between series and parallel. The correct answer is B. Connect 4 12 volts batteries in series for the required voltage. To achieve 48 volts from 12 volts batteries, 4 batteries must be connected in series. Series connections add voltages, 12 volts plus 12 volts plus 12 volts plus 12 volts equals 48 volts, while maintaining the same capacity. Parallel connections would maintain 12 volts while increasing capacity. Question 27. What is the function of a maximum power point tracker in a photovoltaic system? A. To optimize the operating voltage for maximum power extraction. B. To limit the maximum current output during high solar intensity. C. To prevent reverse current flow from batteries to solar panels. D. To synchronize the inverter output with the utility frequency. The correct answer is A. To optimize the operating voltage for maximum power extraction. A maximum power point tracker, MPPT, continuously adjusts the operating point of the solar array to extract maximum power as conditions change. It optimizes the voltage-current relationship to maintain operation at the panel's most efficient point. Question 28. A lithium battery energy storage system shows a cell voltage imbalance alarm. What should be done first? A. Continue operation while monitoring the imbalance trend. B. Replace the individual cells showing the lowest voltage readings. C. Manually equalize the cells by adjusting the charge controller. D. Isolate the system and contact the manufacturer for guidance. The correct answer is D. Isolate the system and contact the manufacturer for guidance. Cell voltage imbalance in lithium battery systems can indicate thermal runaway risk or cell degradation. The system should be isolated immediately and the manufacturer consulted. Lithium batteries require specialized knowledge for safe diagnosis and repair. Question 29. When terminating a 15 kV cable, what step prevents electrical stress concentration at the cable end? A. Applying conductive tape over the cable insulation surface. B. Wrapping the shield with additional layers of semiconductive tape. C. Installing a stress cone or stress control tube at the termination. D. Extending the cable jacket beyond the termination point. The correct answer is C. Installing a stress cone or stress control tube at the termination. Stress cones or stress control tubes are installed at high-voltage cable terminations to gradually transition the electric field from the cable's internal configuration to the air interface. This prevents dangerous voltage concentrations that could cause insulation breakdown. Question 30. What is the minimum bending radius for medium-voltage shielded power cables during installation? A. 6 times the cable diameter for all installation conditions. B. 8 times the cable diameter for permanent training bends. C. 12 times the cable diameter to prevent insulation damage. D. 3 times the cable diameter when using cable guides. The correct answer is C. 12 times the cable diameter to prevent insulation damage. Medium-voltage shielded cables require a minimum bending radius of 12 times the cable diameter to prevent damage to the insulation and shield. Tighter bends can cause shield separation, insulation cracking, and premature cable failure. Question 31. During high-voltage cable testing, the insulation resistance decreases significantly as test voltage increases. What does this indicate? A. Normal behavior for aged cable insulation systems. B. The test equipment requires immediate recalibration. C. Contamination or degradation within the cable insulation. D. Insufficient test duration for accurate measurement. The correct answer is C. Contamination or degradation within the cable insulation. Decreasing insulation resistance with increasing voltage indicates voltage-dependent leakage, typically caused by contamination, moisture intrusion, or insulation degradation. Healthy insulation should maintain consistent resistance regardless of test voltage. Question 32. What determines whether a transformer is classified as extra-low voltage? A. Secondary voltage not exceeding 30 volts AC or 60 volts DC under any condition. B. Primary current rating below 5 amperes for safety isolation. C. Physical size and weight limitations for portable applications. D. Power rating below 100 VA for limited energy applications. The correct answer is A. Secondary voltage not exceeding 30 volts AC or 60 volts DC under any condition. Extra-low voltage transformers produce secondary voltages that do not exceed 30 volts AC or 60 volts DC. This voltage threshold is considered safe from electric shock under most conditions and qualifies for reduced installation requirements. Question 33. When connecting a control transformer with multiple primary voltage taps, what determines which tap to use? A. The physical location of the terminal closest to the supply conductors. B. The ambient temperature rating of the transformer enclosure. C. The maximum expected load current on the secondary circuit. D. The available supply voltage measured at the transformer location. The correct answer is D. The available supply voltage measured at the transformer location. The primary voltage tap selection must match the measured supply voltage at the transformer location. Using the wrong tap results in incorrect secondary voltage, either too high, causing overheating, or too low, causing control device malfunctions. Question 34. When paralleling two three-phase transformers, what must be verified before closing the parallel connection? A. Both transformers have identical power ratings and efficiency. B. The secondary overcurrent protection is equally sized. C. Phase rotation, voltage, and phase angle relationships match. D. Both transformers share identical nameplate serial numbers. The correct answer is C. Phase rotation, voltage, and phase angle relationships match. Before paralleling transformers, phase rotation, voltage magnitude, and phase angle relationships must match exactly. Mismatched phases create circulating currents that overload the transformers and can cause catastrophic failure. Question 35. When installing a pad-mounted transformer, what clearance requirement applies to the access doors? A. Minimum 1.0 meter clearance for single-person maintenance access. B. Clearance equal to the transformer tank width on all sides. C. No clearance required if the transformer is locked. D. Minimum clearance per manufacturer specifications and local utility requirements. The correct answer is D. Minimum clearance per manufacturer specifications and local utility requirements. Pad-mounted transformer access door clearances are determined by manufacturer specifications and local utility requirements. These vary based on voltage class, transformer size, and maintenance requirements, and typically exceed general electrical equipment clearances. Question 36. Oil samples from a transformer show dissolved gas analysis with elevated hydrogen and acetylene. What condition does this indicate? A. Normal aging of the transformer oil requiring scheduled replacement. B. Moisture contamination requiring oil filtration or replacement. C. Active arcing or high-energy electrical discharge inside the transformer. D. Overloading beyond nameplate rating during peak demand periods. The correct answer is C. Active arcing or high-energy electrical discharge inside the transformer. Elevated hydrogen combined with acetylene indicates active arcing or high-energy discharge within the transformer. Acetylene is only produced by arc-type faults and represents a serious condition requiring immediate investigation and possible removal from service. Question 37. When replacing a residential meter socket, what must be coordinated with the utility company? A. The brand and model of meter socket to be installed. B. The depth of the meter socket within the wall cavity. C. The color of the meter socket enclosure for aesthetic consistency. D. Disconnection of service and meter removal before work begins. The correct answer is D. Disconnection of service and meter removal before work begins. Meter socket replacement requires utility coordination for service disconnection and meter removal. The utility must disconnect power at the transformer or service point, remove their meter, and later reinstall and seal the meter after the work is complete. Question 38. A 200 amps feeder breaker trips before the 60 amps branch breaker during an overload on a branch circuit. What is the problem? A. The feeder breaker is defective and requires replacement. B. The branch circuit conductor is undersized for the load. C. Protective device coordination between the breakers is incorrect. D. The main service entrance equipment is improperly grounded. The correct answer is C. Protective device coordination between the breakers is incorrect. When a larger upstream device trips before a smaller downstream device, the protective coordination is incorrect. Proper selective coordination requires that the device closest to the fault operates first, limiting the outage to the affected circuit. Question 39. When installing switchgear in a dedicated electrical room, what determines the minimum working space depth? A. The physical depth of the equipment cabinets being installed. B. The number of technicians expected to work simultaneously. C. The voltage of the equipment and condition of opposite wall surfaces. D. The total ampere rating of the installed service equipment. The correct answer is C. The voltage of the equipment and condition of opposite wall surfaces. Working space depth requirements are determined by the voltage class of the equipment and the condition of surfaces on the opposite side of the working space, grounded, live, or open. Higher voltages and live opposite surfaces require greater clearances. Question 40. What is the minimum size copper conductor permitted for branch circuit wiring in residential occupancies? A. 18 AWG for lighting loads under 10 amperes only. B. 16 AWG when installed in approved raceway systems. C. 12 AWG for all residential branch circuits regardless of load. D. 14 AWG for branch circuits rated 15 amperes or less. The correct answer is D, 14 AWG for branch circuits rated 15 amperes or less. The minimum conductor size for residential branch circuits is 14 AWG copper, which is rated for 15 ampere circuits. Smaller gauge wire does not have sufficient ampacity for standard branch circuit applications and is limited to specific low current uses. Question 41. When calculating conduit fill for 412 AWG THWN conductors, what percentage of the conduit internal area can be occupied? A. 40% for 3 or more conductors in the raceway. B. 31% regardless of the number of conductors. C. 53% for 2 conductors in the raceway. D. 60% for single conductor installations. The correct answer is A, 40% for 3 or more conductors in the raceway. For 3 or more conductors in a conduit, the maximum fill is 40% of the conduit's internal cross-sectional area. This limit applies whether there are 3, 4, or more conductors, allowing for heat dissipation and pulling without damaging conductor insulation. Question 42. What is the maximum number of quarter bends permitted in a single EMT conduit run between pull points? A. 2 quarter bends totaling 180 degrees maximum. B. 3 quarter bends totaling 270 degrees maximum. C. 4 quarter bends totaling 360 degrees maximum. D. 5 quarter bends when using appropriate pulling lubricant. The correct answer is C. 4 quarter bends totaling 360 degrees maximum. The maximum permitted is 4 quarter bends, 360 degrees total, between pull points in a conduit run. Exceeding this limit makes conductor pulling difficult and can damage conductor insulation during installation. Question 43. When calculating box fill, how much volume is required for each 12 AWG conductor entering the box? A. Approximately 32.8 cubic centimeters per conductor. B. Approximately 24.6 cubic centimeters per conductor. C. Approximately 16.4 cubic centimeters per conductor. D. Approximately 8.2 cubic centimeters per conductor. The correct answer is A. Approximately 32.8 cubic centimeters per conductor. Each 12 AWG conductor requires 32.8 cubic centimeters, 2.00 cubic inches, of box volume. This includes allowances for heat dissipation and physical space needed for proper installation and termination. Question 44. A cable pull requires excessive force and the cable stops moving. What should be done? A. Apply additional lubricant and increase the pulling force. B. Continue pulling with mechanical assistance until complete. C. Cut the cable and start the pull from the opposite direction. D. Stop pulling, assess for binding, and consider alternative routing. The correct answer is D. Stop pulling, assess for binding, and consider alternative routing. When a cable pull binds, forcing it can damage conductor insulation or cause cable jacket failure. The correct approach is to stop, investigate the cause of binding, and consider solutions such as reducing the number of conductors, using different lubricant, or modifying the route. Question 45. When installing recessed luminaires in an insulated ceiling, what clearance from combustible insulation is required? A. No clearance required if the fixture is IC rated. B. A minimum 75 mm clearance from all insulation materials. C. Clearance equal to the luminaire diameter on all sides. D. 150 mm clearance from recessed portions of the fixture. The correct answer is A. No clearance required if the fixture is IC rated. IC rated, insulation contact, luminaires are specifically designed and tested for direct contact with thermal insulation. Non-IC rated fixtures require minimum clearances to prevent heat buildup and fire hazard. Question 46. What is the typical mounting height for a wall receptacle outlet in a residential dwelling? A. 200 mm from finished floor to bottom of the device box. B. 300 mm from finished floor to center of the device box. C. 400 mm from finished floor to top of the device box. D. Height varies based on local practice and accessibility. The correct answer is C. 400 mm from finished floor to top of the device box. The typical mounting height is approximately 400 mm, 16 inches, from the finished floor to the top of the device box. This is common industry practice rather than a code-mandated requirement. Actual heights may vary based on accessibility needs and local preferences. Question 47. When installing a dimmer switch for LED luminaires, what must be verified for compatibility? A. The dimmer wattage rating exceeds the LED wattage by 100%. B. Both the dimmer and LED drivers are rated for dimming compatibility. C. The LED luminaires use standard incandescent lamp holders. D. The dimmer uses pulse width modulation at 60 Hz. The correct answer is B. Both the dimmer and LED drivers are rated for dimming compatibility. LED dimming requires compatible dimmer switches and LED drivers. Not all dimmers work with all LED products. Incompatible combinations cause flickering, buzzing, limited dimming range, or premature failure. Both components must be verified as compatible. Question 48. When installing a parking lot lighting standard, what foundation requirement applies? A. Direct burial in soil is acceptable for standards under 3 meters. B. Metal plates welded to the pole base for surface mounting. C. Wooden cribbing is acceptable for temporary installations only. D. A concrete base with anchor bolts matching the pole base pattern. The correct answer is D. A concrete base with anchor bolts matching the pole base pattern. Parking lot lighting standards require engineered concrete foundations with anchor bolts matching the specific pole base pattern. These foundations must resist wind loads and provide stable, level mounting for the life of the installation. Question 49. A 20 amps branch circuit breaker trips repeatedly when a specific receptacle load is connected. The load draws 15 amps. What is the most likely cause? A. Other loads on the circuit create combined current exceeding 20 amps. B. The circuit breaker is defective and has reduced trip threshold. C. The receptacle has high resistance causing excessive heat generation. D. The load has a high inrush current during startup that trips the breaker. The correct answer is A. Other loads on the circuit create combined current exceeding 20 amps. A 15 amps load on a 20 amp circuit should not trip the breaker alone. The most common cause is other existing loads on the same circuit that, combined with the new load, exceed the 20 amps rating. Checking total circuit loading identifies if load redistribution is needed. Question 50. What distinguishes runway edge lighting circuits from standard commercial lighting circuits? A. Runway circuits use series-connected constant current regulators. B. Runway circuits operate at extra low voltage for pilot safety. C. Runway circuits use standard parallel wiring with larger conductors. D. Runway circuits require grounded neutral conductors at each fixture. The correct answer is A. Runway circuits use series-connected constant current regulators. Airfield lighting uses series-connected circuits with constant current regulators. Unlike parallel circuits, series circuits maintain consistent brightness across all fixtures regardless of cable length. Current regulators adjust voltage to maintain specified current levels. Question 51. When installing underground wiring to a traffic signal controller, what enclosure type is required? A. Standard electrical PVC conduit with weatherproof fittings. B. Flexible metal conduit for vibration resistance near the roadway. C. Schedule 80 PVC or rigid metal conduit with drainage provisions. D. Direct burial cable rated for traffic signal applications. The correct answer is C. Schedule 80 PVC or rigid metal conduit with drainage provisions. Traffic signal underground wiring requires Schedule 80 PVC or rigid metal conduit for physical protection and longevity. Drainage provisions prevent water accumulation that could damage conductors or create ground faults in the control circuits. Question 52. When connecting a rooftop air handling unit, what type of wiring method provides required flexibility? A. Flexible metal conduit or liquid-tight flexible conduit at the unit. B. Rigid metal conduit with expansion fittings at the connection. C. Armored cable directly attached to the unit terminal box. D. EMT conduit with seal-tight fittings for weather protection. The correct answer is A. Flexible metal conduit or liquid-tight flexible conduit at the unit. Flexible metal conduit or liquid-tight flexible conduit is required at equipment connections where vibration or movement occurs. This flexibility prevents conduit and connection damage from equipment operation and accommodates minor alignment variations. Question 53. When installing a thermostat cable for an HVAC system, what determines the number of conductors required? A. The distance from the thermostat to the HVAC equipment. B. The control functions required by the heating and cooling system. C. The voltage level of the control transformer secondary. D. The amperage rating of the HVAC unit compressor circuit. The correct answer is B. The control functions required by the heating and cooling system. Thermostat wire conductor count depends on the control functions needed: heat, cool, fan, multiple stages, and common. Simple systems may need only 2 wires, while heat pumps with auxiliary heat and multiple stages require 8 or more conductors. Question 54. An air conditioning compressor motor draws higher than normal current but starts and runs. What should be investigated first? A. Whether the motor windings have developed a short circuit. B. If the capacitor has failed and needs immediate replacement. C. The refrigerant charge level and system operating pressures. D. Whether the motor bearings are seizing due to lack of lubrication. The correct answer is C. The refrigerant charge level and system operating pressures. High current draw on a running compressor typically indicates abnormal system pressures from incorrect refrigerant charge, a restriction, or condenser issues. Electrical problems usually prevent starting rather than causing elevated running current. Question 55. When installing electric baseboard heaters, what clearance from the floor is required? A. Mounted directly on the floor for maximum heat distribution. B. Approximately 25 mm minimum clearance from the finished floor. C. 100 mm minimum to allow air circulation beneath the unit. D. Clearance varies based on heater wattage and room size. The correct answer is B. Approximately 25 mm minimum clearance from the finished floor. Electric baseboard heaters require approximately 25 mm, 1 inch, clearance from the floor to allow proper convective air flow. This gap allows cool air to enter at the bottom, pass over the heating element, and exit at the top. Question 56. When installing a line voltage thermostat for baseboard heaters, how is the thermostat connected? A. In parallel with the heating elements for temperature sensing. B. In series with the heating elements to control current flow. C. To the neutral conductor only for ground fault protection. D. To a separate low voltage transformer for control power. The correct answer is B. In series with the heating elements to control current flow. Line voltage thermostats are connected in series with the heating elements, acting as a switch that opens and closes the circuit based on temperature. All load current flows through the thermostat, which must be rated for the heater amperage. Question 57. A baseboard heater produces a burning smell when operating. What is the most probable cause? A. Dust accumulation on the heating elements burning off. B. Overloaded circuit causing conductor insulation overheating. C. Defective thermostat contacts arcing during switching. D. Incompatible wattage rating for the circuit conductor size. The correct answer is A. Dust accumulation on the heating elements burning off. Burning smell from baseboard heaters at startup is typically caused by dust accumulation on the heating elements, especially after periods of non-use. While concerning, this is usually temporary. Persistent smell indicates investigation of connections and components. Question 58. What wiring method is required for emergency lighting circuits to ensure reliability? A. Standard NMD cable identical to regular lighting circuits. B. Wireless communication between emergency lighting fixtures. C. Underground conduit systems to protect from building fires. D. Wiring protected by fire-rated construction or fire-rated cable. The correct answer is D. Wiring protected by fire-rated construction or fire-rated cable. Emergency lighting circuit wiring must be protected to survive fire conditions long enough to allow building evacuation. This requires fire-rated enclosures, fire-rated cables, or protection by fire-rated building construction to maintain circuit integrity. Question 59. How often must emergency lighting unit batteries be tested for duration under load? A. Weekly visual inspection of indicator lights only. B. Monthly 30-second functional test and annual 30-minute duration test. C. Quarterly full duration testing with replacement every 2 years. D. Only when the unit indicator shows low battery condition. The correct answer is B. Monthly 30-second functional test and annual 30-minute duration test. Emergency lighting requires monthly 30-second functional tests to verify operation, plus annual 30-minute, or 60-minute where required, duration tests to confirm battery capacity. These tests are typically documented for code compliance verification. Question 60. What is the purpose of a cathodic protection system on buried metallic structures? A. To provide lightning protection for the buried structure. B. To prevent galvanic corrosion by making the structure cathodic. C. To detect ground faults on circuits connected to the structure. D. To bond multiple underground structures together electrically. The correct answer is B. To prevent galvanic corrosion by making the structure cathodic. Cathodic protection systems prevent corrosion by making the protected structure a cathode, negative electrode, in an electrochemical cell. This transfers corrosion from the protected structure to sacrificial anodes or an impressed current system. Question 61. When testing an impressed current cathodic protection system, what measurement indicates proper operation? A. Zero voltage between the structure and remote earth reference. B. Balanced voltage between all anodes in the ground bed. C. Positive current flow from the structure to the anode bed. D. Negative potential on the protected structure relative to a reference cell. The correct answer is D. Negative potential on the protected structure relative to a reference cell. A properly operating impressed current cathodic protection system creates a negative potential on the protected structure relative to a standard reference cell, typically copper sulfate. This negative potential indicates cathodic polarization is occurring. Question 62. When more than 3 current-carrying conductors are installed in a conduit, what factor must be applied? A. A fill derating factor based on conduit cross-sectional area. B. A voltage drop calculation based on total circuit length. C. A temperature correction based on ambient conditions only. D. An ampacity correction factor that reduces the conductor rating. The correct answer is D. An ampacity correction factor that reduces the conductor rating. When more than 3 current-carrying conductors share a conduit, an ampacity correction factor must be applied because mutual heating reduces each conductor's capacity. Factors range from 80% for 4 to 6 conductors down to 35% for 41 plus conductors. Question 63. What is the maximum support spacing requirement for horizontal runs of EMT conduit? A. Every 1.2 meters with a support within 300 millimeters of each box. B. Every 1.5 meters with a support within 450 millimeters of each box. C. Every 3.0 meters with a support within 900 millimeters of each box. D. Every 4.0 meters with a support within 1,200 millimeters of each box. The correct answer is C. Every 3.0 meters with a support within 900 millimeters of each box. EMT requires support at intervals not exceeding 3.0 meters, 10 feet, for horizontal runs, with a support within 900 millimeters, 3 feet, of each outlet box, junction box, cabinet, or fitting. This prevents sagging and ensures a secure installation. Question 64. When installing cables in a ladder-type cable tray, how should single conductors be arranged? A. Randomly placed with adequate ventilation space between cables. B. Bundled together in groups of 3 for thermal efficiency. C. Arranged in single layer with phases grouped to minimize heating. D. Stacked vertically with the largest conductors on the bottom. The correct answer is C. Arranged in single layer with phases grouped to minimize heating. Single conductors in cable trays should be arranged in a single layer with phases grouped together, triplex or adjacent, to minimize inductive heating. This arrangement cancels magnetic fields and allows proper heat dissipation from all conductors. Question 65. What distinguishes a 20 amps receptacle from a 15 amps receptacle in the same voltage class? A. The 20 amps receptacle is larger in overall dimensions. B. The 20 amps receptacle has a T-shaped neutral slot. C. The 20 amps receptacle uses different colored terminals. D. The 20 amps receptacle has a different ground pin location. The correct answer is B. The 20 amps receptacle has a T-shaped neutral slot. A 20 amps receptacle has a T-shaped neutral slot that accepts both 20 amps plugs, with a horizontal prong, and 15 amps plugs, with a vertical prong. This configuration allows 15 amps equipment to be used on 20 amp circuits while preventing 20 amps equipment on 15 amp circuits. Question 66. What type of cover is required on outdoor receptacles where they may be used with an attachment plug inserted? A. A standard weatherproof cover that closes when the plug is removed. B. A heavy-duty metal cover with drainage holes at the bottom. C. A lockable cover that prevents unauthorized access to the receptacle. D. A cover rated as weather-resistant while the plug remains inserted. The correct answer is D. A cover rated as weather-resistant while the plug remains inserted. Outdoor receptacles that may be used with equipment plugged in during rain require covers rated extra duty or in use that maintain weather resistance while the attachment plug is inserted. Standard covers only protect when closed without a plug. Question 67. When installing wall-mounted occupancy sensors, what location provides optimal detection coverage? A. Centered on the longest wall at door handle height for accessibility. B. Adjacent to the entry door at switch height for consistent operation. C. On the ceiling directly above the primary work area in the room. D. Opposite the entry door to detect occupants entering the space. The correct answer is B. Adjacent to the entry door at switch height for consistent operation. Wall-mounted occupancy sensors are typically installed adjacent to the entry door at switch height. This location captures motion as occupants enter, provides a clear detection path into the room, and allows manual override access similar to a light switch. Question 68. When connecting a furnace blower motor with color-coded leads, how are typical speed connections made? A. Black is high speed, blue is medium, red is low, and white is common. B. All colored leads connect together for single-speed operation. C. Speed selection is made by jumpers inside the motor housing. D. Each lead connects to a separate circuit breaker for speed control. The correct answer is A. Black is high speed, blue is medium, red is low, and white is common. Multi-speed furnace motors typically use standard color coding, black for high speed, blue or yellow for medium, red for low speed, and white for the common connection. The thermostat or control board selects the appropriate speed tap for heating or cooling modes. Question 69. When installing electric radiant floor heating cables, what test must be performed before covering the cables with flooring? A. Voltage measurement to confirm correct circuit connection. B. Insulation resistance measurement with the floor at operating temperature. C. Resistance and insulation resistance measurements with results recorded. D. Amperage measurement to verify heating cable is drawing correct current. The correct answer is C. Resistance and insulation resistance measurements with results recorded. Before covering radiant floor heating cables, both resistance and insulation resistance must be measured and documented. These baseline readings allow comparison if problems develop later and verify the cable was not damaged during installation. Question 70. What minimum illumination level must an exit sign provide on the word exit? A. 50 lux measured at the sign face from any viewing angle. B. Sufficient illumination to be clearly visible from 30 meters. C. 53.8 lux, 5-foot candles, measured at the illuminated surface. D. 100 lux measured perpendicular to the sign surface. The correct answer is C. 53.8 lux, 5-foot candles, measured at the illuminated surface. Exit signs must provide a minimum of 53.8 lux, 5-foot candles, at the illuminated surface. This brightness level ensures visibility under both normal conditions and during emergencies when ambient lighting may be reduced or absent. Question 71. What distinguishes a capacitor start motor from a split-phase motor in terms of starting characteristics? A. The capacitor start motor uses a centrifugal switch to disconnect the run winding. B. The split-phase motor operates at higher efficiency during full load conditions. C. The split-phase motor requires an external relay to energize the start winding. D. The capacitor start motor develops higher starting torque due to improved phase angle. The correct answer is D. The capacitor start motor develops higher starting torque due to improved phase angle. A capacitor start motor develops significantly higher starting torque than a split-phase motor because the capacitor creates a greater phase angle between start and run winding currents. This improved phase displacement results in a stronger rotating magnetic field during startup, making capacitor start motors suitable for hard-to-start loads. Question 72. When connecting a dual-voltage 3-phase motor rated 208/416 volts, which connection achieves the higher voltage rating? A. Connecting the 9 leads in a Y configuration with all windings in parallel. B. Connecting the 9 leads in a delta configuration with windings in series. C. Connecting the 6 leads with T1, T4, T2, T5, T3, T6 joined together. D. Connecting the 9 leads with T4, T7, T5, T8, T6, T9 series combinations. The correct answer is D. Connecting the 9 leads with T4, T7, T5, T8, T6, T9 series combinations. For dual-voltage 3-phase motors, the higher voltage rating is achieved by connecting the windings in series. With a 9-lead motor, this means joining T4, T7, T5, T8, and T6, T9 in series combinations. The line connections go to T1, T2, T3, with T7, T8, T9 connected to T4, T5, T6 respectively for the series path. Question 73. What must be verified before connecting a compound DC motor to ensure proper operation? A. The armature resistance matches the field winding resistance exactly. B. The brush position is set at maximum advancement for highest speed. C. The series and shunt field polarities are connected for cumulative compounding. D. The interpole windings are disconnected to prevent regenerative braking. The correct answer is C. The series and shunt field polarities are connected for cumulative compounding. For a compound DC motor, the series and shunt field polarities must be connected for cumulative compounding, where both fields aid each other. Differential compounding, fields opposing, causes unstable operation and potential runaway. The connection is verified by observing that the motor develops proper torque under load. Question 74. A 3-phase motor runs normally unloaded but trips on overload when the driven load is connected. The motor current is balanced on all 3 phases. What is the most likely cause? A. The mechanical load exceeds the motor's rated horsepower capacity. B. The motor is experiencing single-phase operation from a blown fuse. C. The motor has a shorted stator winding causing excessive current. D. The overload relay heaters are sized too large for the application. The correct answer is A. The mechanical load exceeds the motor's rated horsepower capacity. Since the motor runs normally unloaded with balanced currents, the electrical system is functioning properly. Single phasing would show unbalanced currents, and shorted windings would trip even at no load. The problem is mechanical. The driven load requires more horsepower than the motor can deliver, causing overload conditions only when the load is applied. Question 75. When installing a manual motor starter for a fractional horsepower motor, what determines the required starter size? A. The available short-circuit current at the installation point. B. The motor full load current and required overload protection rating. C. The conductor size feeding the motor from the branch circuit panel. D. The ambient temperature at the starter mounting location only. The correct answer is B. The motor full load current and required overload protection rating. Manual motor starters are sized based on the motor's full load current and the required overload protection. The starter must be rated to carry the motor's continuous current and provide overload protection typically at 115 to 125% of the motor FLA. Short-circuit protection is provided separately by the branch circuit breaker or fuses. Question 76. What is the function of the auxiliary contact marked OL in a magnetic motor starter holding circuit? A. It provides a normally closed contact that opens when overload trips. B. It provides a normally open contact that seals in the starter coil. C. It provides voltage feedback to the motor for speed regulation. D. It provides ground fault detection for the motor circuit conductors. The correct answer is A. It provides a normally closed contact that opens when overload trips. The auxiliary contact marked OL is a normally closed contact wired in series with the starter coil circuit. When the overload relay trips due to excessive motor current, this contact opens, interrupting the coil circuit and de-energizing the contactor. This stops the motor and requires manual reset before restarting. Question 77. A reversing motor starter chatters when the reverse push button is pressed but operates smoothly in forward. All control voltages measure correctly. What should be checked first? A. The mechanical and electrical interlocks between the two contactors. B. The forward contactor coil resistance compared to the reverse coil. C. The reverse push button contact resistance during depression. D. The motor winding insulation resistance in the reverse direction. The correct answer is A. The mechanical and electrical interlocks between the two contactors. Contactor chatter in only one direction suggests an interlock issue. Reversing starters have mechanical and electrical interlocks to prevent both contactors from energizing simultaneously. If the mechanical interlock is binding or the electrical interlock contact on the forward contactor isn't making properly, the reverse contactor coil receives intermittent power, causing chatter. Question 78. When testing a starter coil with an ohm meter, what resistance reading indicates a shorted coil condition? A. A reading significantly higher than the coil's normal rated resistance. B. A reading significantly lower than the coil's normal rated resistance. C. An infinite reading when measuring across the coil terminals. D. A fluctuating reading that varies with ambient temperature. The correct answer is B. A reading significantly lower than the coil's normal rated resistance. A shorted coil shows significantly lower resistance than normal because some turns are bypassed by the short circuit. The reduced impedance causes excessive current flow when energized. A reading higher than rated indicates corroded connections or high resistance faults, while infinite resistance means an open coil. Question 79. What is the primary advantage of a variable frequency drive compared to a reduced voltage starter for motor speed control? A. The VFD eliminates the need for motor overload protection devices. B. The VFD operates motors at unity power factor under all load conditions. C. The VFD requires smaller conductors due to reduced starting current only. D. The VFD provides continuous speed adjustment with constant torque capability. The correct answer is D. The VFD provides continuous speed adjustment with constant torque capability. A variable frequency drive provides true speed control by varying both frequency and voltage to maintain the volts per hertz ratio. This allows continuous, infinitely adjustable speed while maintaining constant torque throughout the speed range. Reduced voltage starters only limit starting current, they cannot control running speed. Question 80. When installing a VFD, what is the required minimum distance between the drive output cables and sensitive control wiring? A. There is no minimum distance if both are in metallic conduit. B. Only separation is needed at the VFD enclosure termination points. C. The cables must be in separate cable trays on opposite sides of the room. D. At least 300 mm with shielded cables or metallic conduit separation. The correct answer is D. At least 300 mm with shielded cables or metallic conduit separation. VFD output cables carry high-frequency switching waveforms that generate electromagnetic interference. A minimum separation of 300 mm, 12 inches, between VFD motor cables and sensitive control or signal wiring is required, even when using shielded cables or metallic conduit. Greater separation is preferred where practical. Question 81. A VFD displays a DC bus overvoltage fault during deceleration of a high inertia load. What modification would resolve this issue? A. Installing a larger input line reactor to limit charging current. B. Reducing the motor voltage parameter to lower back EMF levels. C. Adding dynamic braking resistors to dissipate regenerative energy. D. Increasing the carrier frequency to improve current waveform quality. The correct answer is C. Adding dynamic braking resistors to dissipate regenerative energy. During deceleration of a high inertia load, the motor acts as a generator, feeding energy back to the VFD DC bus. This raises the DC bus voltage above the overvoltage trip point. Dynamic braking resistors provide a path to dissipate this regenerative energy as heat, preventing the overvoltage condition and allowing controlled deceleration. Question 82. When installing a motor control center, what clearance is required in front of the equipment for 600 volts installations? A. 0.6 meters for equipment with doors that open less than 90 degrees. B. 1.2 meters when grounded parts are opposite the live front panel. C. 1.0 meter minimum working space for all 600 volts motor control centers. D. 0.9 meters when the equipment is in a dedicated electrical room. The correct answer is C. 1.0 meter minimum working space for all 600 volts motor control centers. For motor control centers rated 601 volts to 750 volts, which includes 600 volt systems, the minimum clear working space in front of the equipment is 1.0 meter. This allows safe operation, inspection, and maintenance of the equipment. Additional clearance may be required depending on conditions opposite the equipment. Question 83. What determines the required cross-sectional area of the MCC vertical ground bus? A. The total connected motor horsepower in the motor control center. B. The largest equipment grounding conductor size connected to the bus. C. The main horizontal bus ampacity rating divided by the number of sections. D. The available fault current at the point of supply to the MCC. The correct answer is B. The largest equipment grounding conductor size connected to the bus. The vertical ground bus in an MCC must be sized to accommodate the largest equipment grounding conductor connected to it. This ensures adequate fault current carrying capacity for the largest load. The bus must also maintain mechanical strength and proper connection integrity for all grounding conductors. Question 84. During annual maintenance, infrared scanning of an MCC reveals one horizontal bus connection is 40 degrees Celsius above ambient while others are at ambient. What is the appropriate action? A. Continue monitoring the connection monthly until temperature rises further. B. Reduce the load current on that section until the next scheduled outage. C. Apply thermal compound to the connection to improve heat dissipation. D. Schedule immediate shutdown to inspect and retorque the connection. The correct answer is D. Schedule immediate shutdown to inspect and retorque the connection. A 40 degrees Celsius temperature rise above ambient indicates a serious high-resistance connection that requires immediate attention. High-resistance joints continue to deteriorate and can lead to arcing, fire, or equipment failure. The connection must be de-energized, inspected for damage, cleaned if necessary, and properly re-decayed to the manufacturer's specifications. Question 85. When wiring field devices to PLC discrete input modules, what configuration prevents false input signals from electrical noise? A. Using unshielded twisted pair cable for all input wiring connections. B. Routing input wiring in the same conduit as motor power cables. C. Installing input filter modules or RC snubbers across dry contacts. D. Connecting multiple inputs in parallel to verify signal redundancy. The correct answer is C. Installing input filter modules or RC snubbers across dry contacts. Input filter modules or RC snubbers installed across dry contacts filter out high-frequency electrical noise that can cause false input signals. This is especially important in industrial environments where VFDs, motor starters, and other equipment generate electromagnetic interference that can be picked up by long input cable runs. Question 86. What is the proper grounding configuration for a PLC analog input module receiving a 4 to 20 mA signal from a remote transmitter? A. Ground the signal shield at both the transmitter and PLC ends. B. Connect the shield to the transmitter case and PLC chassis simultaneously. C. Leave the signal shield ungrounded to maximize electrical isolation. D. Ground the signal shield at the PLC end only to prevent ground loops. The correct answer is D. Ground the signal shield at the PLC end only to prevent ground loops. Analog signal cable shields should be grounded at one end only, preferably at the PLC receiving end. Grounding at both ends creates a ground loop where differences in ground potential cause circulating currents that add noise to the analog signal. Single-point grounding provides shielding while avoiding this issue. Question 87. When installing a proximity sensor for position detection on a conveyor system, what determines the sensing distance? A. The target material, size, and the sensor's rated sensing range. B. The supply voltage applied to the sensor's input terminals. C. The cable length from the sensor to the PLC input module. D. The ambient temperature at the sensor mounting location. The correct answer is A. The target material, size, and the sensor's rated sensing range. Proximity sensor detection distance depends on the target material. Ferrous metals sense from greater distance than non-ferrous. The target size must meet minimum size for rated distance, and the sensor's specified sensing range. These factors must be considered during sensor selection and installation to ensure reliable operation. Question 88. A PLC-controlled process intermittently stops with no fault codes displayed. The problem occurs only during peak production hours. What diagnostic approach is most appropriate? A. Replace the PLC processor module with a spare unit for comparison. B. Increase the scan time to allow more processing time for the program. C. Upgrade the PLC program to the latest firmware version available. D. Monitor input and output status during peak hours to identify signal dropouts. The correct answer is D. Monitor input and output status during peak hours to identify signal dropouts. Intermittent problems occurring only during peak production suggest external factors affecting PLC inputs or outputs. Monitoring the I/O status in real time during peak hours can reveal signal dropouts from electrical noise, voltage fluctuations, or overloaded outputs. This targeted approach identifies the actual failure point rather than making speculative changes. Question 89. When performing insulation resistance testing on a motor, what is the minimum acceptable reading for a 600 volts motor? A. 0.5 megohms measured at the motor operating temperature. B. 1 megohm plus 1 megohm per 1000 volts of rated voltage. C. 10 megohms minimum regardless of voltage rating or size. D. 100 megohms for motors in continuously damp environments. The correct answer is B, 1 megohm plus 1 megohm per 1000 volts of rated voltage. The industry standard for minimum acceptable insulation resistance is 1 megohm plus 1 megohm per 1000 volts of rated voltage. For a 600 volts motor, this means 1 plus 0.6 is equal to 1.6 megohms minimum. However, new or reconditioned motors should show much higher values. Readings near the minimum indicate degrading insulation requiring attention. Question 90. When adjusting an electronic overload relay for a 40 amps full load current motor, what trip class is typically selected for standard motor applications? A. Class 5 for rapid tripping on slight overloads to protect the motor. B. Class 30 which allows maximum starting time for severe duty applications. C. Class 20 for motors with high inertia loads requiring extended acceleration. D. Class 10 which provides standard protection for most motor applications. The correct answer is D, Class 10 which provides standard protection for most motor applications. Class 10 overload relays are the standard selection for most motor applications. They will trip within 10 seconds at 600% of the motor full load current, providing balanced protection between allowing normal starting current and protecting against sustained overloads. Class 20 and 30 are for special high inertia applications. Question 91. What distinguishes a Class A fire alarm initiating circuit from a Class B circuit in terms of wiring configuration? A. Class A circuits operate at 24 volts DC while Class B operates at 12 volts DC. B. Class A circuits use a return path that maintains operation with a single open. C. Class B circuits require supervised wiring while Class A does not. D. Class B circuits can connect more devices per zone than Class A. The correct answer is B. Class A circuits use a return path that maintains operation with a single open. Class A fire alarm circuits, style Z or 6-7, are configured with a return path to the control panel, allowing the circuit to maintain operation even with a single wire open. The signal can reach devices from either direction. Class B circuits have a single path with an end-of-line resistor and lose supervision of devices beyond an open. Question 92. When installing fire alarm circuit conductors, what is the maximum support spacing for cables in a vertical raceway? A. Every 1.5 meters with approved cable ties or supports. B. Support at the top and bottom only for runs under 15 meters. C. Maximum 3-meter intervals with listed cable support systems. D. Support is only required where the cable enters enclosures. The correct answer is A. Every 1.5 meters with approved cable ties or supports. Fire alarm circuit cables in vertical raceways must be supported at intervals not exceeding 1.5 meters to prevent conductor damage and maintain circuit integrity. This prevents excessive cable weight from damaging insulation or pulling connections loose. Support must be provided with approved cable supports or ties. Question 93. A fire alarm panel displays a ground fault on Zone 3, but Megger testing of the zone wiring shows acceptable insulation resistance. What is the most likely cause? A. A detector base is installed on a metal junction box without isolation. B. The end-of-line resistor has drifted out of tolerance range. C. The zone module in the fire alarm panel has failed internally. D. The panel's ground fault detection circuit requires recalibration. The correct answer is A. A detector base is installed on a metal junction box without isolation. Fire alarm detectors mounted on grounded metal boxes can create a partial ground path that the panel detects as a ground fault, even though the circuit insulation resistance is acceptable. The detector base may be making contact with the grounded box through mounting screws or internal components. Installing an insulating detector base or using a plastic box resolves this. Question 94. When installing balanced magnetic contacts for door security monitoring, why is a spacer used between the magnet and switch? A. To prevent false alarms caused by door vibration and slight misalignment. B. To increase the operating distance for wider door gap tolerances. C. To protect the switch from direct impact if the door strikes it. D. To allow temperature compensation for the magnetic field strength. The correct answer is B. To increase the operating distance for wider door gap tolerances. The spacer in a balanced magnetic contact system sets the correct operating gap between the magnet and switch. This establishes the balanced condition where the internal reference magnet and external door magnet create opposing fields. The gap tolerance allows for normal door movement without triggering false alarms. Question 95. What is the required mounting height for a nurse call pull cord station in a patient bathroom? A. The cord must reach within 150 mm of the finished floor level. B. The pull ring must be mounted between 1200 mm and 1500 mm above floor. C. The station is mounted at standard switch height of 1200 mm. D. The activation point must be between 450 mm and 600 mm from floor. The correct answer is A. The cord must reach within 150 mm of the finished floor level. Nurse call pull cord stations in bathrooms must have the cord extending to within 150 mm, 6 inches, of the finished floor. This allows a patient who has fallen to reach and activate the emergency call from floor level. The mounting height of the station itself is secondary to ensuring the pull cord reaches the required low point. Question 96. When terminating category 6 amps shielded twisted pair cable, what is the maximum untwist length allowed for each pair at the connector? A. No more than 13 mm of untwisted conductor at each termination point. B. Up to 25 mm of untwisting is permitted for easier connection. C. The pairs may be fully untwisted within the connector housing. D. Maximum 75 mm measured from the cable jacket to the contact. The correct answer is A. No more than 13 mm of untwisted conductor at each termination point. Category 6 amps cable termination requires maintaining the twist as close to the termination point as possible. Maximum untwist length is 13 mm, approximately 1/2 inch, per pair. Excessive untwisting degrades the cable's crosstalk rejection and can prevent the link from meeting Category 6 amps performance specifications. Question 97. A structured cabling installation fails certification testing with excessive next, near-end crosstalk, on multiple links. All connectors were properly terminated. What is the most likely systemic cause? A. The cable pairs were split between different patch panel ports. B. The horizontal cable runs exceed the 90-meter maximum length. C. The patch cables are using mismatched wire mapping standards. D. The cable runs are routed adjacent to fluorescent lighting fixtures. The correct answer is C. The patch cables are using mismatched wire mapping standards. Excessive next across multiple links with properly terminated connectors suggests a wire mapping mismatch. If patch cables are wired to one standard, T568 amps, and the permanent link uses another, T568B, the pairs align incorrectly, dramatically increasing crosstalk. All components in a channel must use consistent pin/pair assignments. Question 98. When installing coaxial cable for a community antenna distribution system, what causes signal degradation at connection points? A. Using connectors rated for higher frequencies than required. B. Routing the cable through plastic conduit instead of metal raceways. C. Installing connectors in accessible locations above suspended ceilings. D. Improper preparation leaving the center conductor too short or exposed shielding. The correct answer is D. Improper preparation leaving the center conductor too short or exposed shielding. Coaxial cable connections are critical points for signal integrity. If the center conductor is too short, it won't make solid contact. If the shield braid or foil is exposed or makes contact with the center conductor, it creates an impedance mismatch and signal reflection. Proper cable preparation with the correct dimensions for the connector type is essential. Question 99. When installing a building automation system controller, what determines the required wire gauge for the communication bus? A. The communication protocol specification and maximum cable run length. B. The total power consumption of all devices on the communication bus. C. The ambient temperature of the spaces through which the cable passes. D. The number of controllers connected to a single network segment. The correct answer is A. The communication protocol specification and maximum cable run length. BAS communication bus wire gauge is determined by the protocol specification, such as BACnet MS/TP or LANWorks, and the maximum cable run length. Different protocols have specific requirements for conductor gauge, cable type, and topology to ensure reliable data transmission. Longer runs typically require larger gauge conductors to maintain signal quality. Question 100. An integrated building system intermittently loses communication with remote controllers. The communication bus is properly terminated and grounded. What troubleshooting step should be performed first? A. Replace all the controllers on the communication bus with new units. B. Measure the communication bus signal voltage levels at multiple points. C. Upgrade the central controller firmware to the latest available version. D. Install additional repeaters to boost the signal strength throughout. The correct answer is B. Measure the communication bus signal voltage levels at multiple points. Intermittent communication issues on a properly terminated and grounded bus suggest signal integrity problems. Measuring the communication bus voltage at multiple points reveals where signal degradation occurs, identifying cable damage, connection problems, or excessive loading. This targeted approach locates the actual problem rather than making speculative replacements. Thank you for practicing with Question Bank Hub. Good luck on your Construction Electrician Red Seal certification exam. Don't forget to subscribe for more exam preparation content.